This is going to be lesson 6.1 on similar polygons. So we're starting off unit 6, which is all about similarity and similarity of triangles specifically. So we've already learned about congruence of triangles and congruent figures, and you've learned how to write congruent statements and different triangle congruence theorems. We're going to learn similar things with similarity. So for today, we're going to talk about what a similarity statement means and what a scale factor is and how to find a scale factor of two similar figures. So think about in the real world, what kind of things are you would use similarity and scale factors in. You can think art, architecture. Similarity goes into many different subjects. So for today, we're going to write similarity statements and use proportions to determine if polygons are similar and use scale factors. So what does similarity mean? Similar polygons mean that they have that the corresponding angles are congruent. So corresponding angles are congruent. So the angles are congruent, but the sides are not congruent. They are proportional. So side lengths are proportional. Keyword there. All right, so if you were to draw a picture based on maybe a little picture that you took, like if you were to scale it up and draw a big portrait, you want to make sure all parts are proportional, and if they're not, then it's not going to look like the original figure. All right, so a similarity statement is corresponding sides and vertices are listed in the same order. So corresponding sides and vertices are listed in the same order. And the symbol we use for similarity is just a little squiggle, the tilde sign. Where congruent, we use the tilde and equals to underneath. Okay, this just means proportional to, similar to. So here we have polygon ABCD, EFGH, and we have this as an example of a similarity statement. We just say ABCD is similar to EFGH. So all of the congruent vertices are listed in the same order. Okay, you could also then go to say that, well, statement of proportionality is another term that you're going to see. So statement, write that down, of proportionality is where you write the proportional sides equal to each other. So we'll start with AB over, so the ratio of AB to EF, so AB and EF are going to be proportional sides. That ratio should be the same as all the other ones. So BC to FG, and that should be equal to CD to GH, and then that should be equal to DA to HE. So DA to HE. All right, so notice kind of like with congruence, we use tick marks. With similarity, and I don't know if this is really in the book, but this is just some markings I find helpful, is to do a squiggle to indicate the corresponding proportional sides. All right, so here's an example. So we know that triangle RST is similar to triangle XYZ. So RST, you might just want to go through and make sure, because sometimes they might like flip the other triangle. So RST and then XYZ. Okay, so it's kind of in the same, all we did was like translated and then dilated the figure. So list all pairs of congruent angles. Okay, so I'm just gonna go ahead and mark them congruent. So R and X S and Y can get 2 arcs, and then T and Z can get 3 arcs. All right, so I've named them. You can write it out if you would like. And then check that the ratios of the corresponding side lengths are equal. All right, so let's check RS to XY. So RS to XY, we'll find that one, and then we'll find ST to YZ, and then we'll find TR to ZY. All right, so let's go ahead and find those. We'll simplify, reduce your fractions. So 20 over 12 those are both divisible by 4, so 5/3. Okay, so then we want to check that all the other ones are 5/3. So 30 over 18. Those are both divisible by 6. That would be 5/3. So that checks off. And then the other one is 25 to 15, both divisible by 5. So we get 5/3 again. All right, so we proved part B. We checked that. And then write the ratios of the corresponding side lengths in a statement of proportionality. So this is what you would do like from the last one. So you would say RS to XY equals ST to YZ equals TR to ZY. So you see now how those ratios are all equal to each other. That's what statement of proportionality is just saying, okay? All right, so then scale factor is the ratio of the lengths of two corresponding sides. So it's the ratio, typically written as a fraction, reduced fraction, of the lengths of two corresponding sides in similar polygons. So in the last example, the scale factor of this triangle to that triangle is 5/3. Okay, now if we went from this triangle to that triangle, it would be 3/5. All right, so here, so basically you take the side length of one and then to the side length of the other, and you just divide and simplify the fraction. So determine whether the polygons are similar. If they are, write a statement of proportionality, write a similarity statement, and find the scale factor of ZYXW to FGHJ. So let's do that. So we're going to do this polygon to this one. So let's check the side lengths based off of the congruent angle marking. So let's do, I would know that these ones, if they were similar, these two sides would be proportional because they're in between the right angle and the one tick mark. So 20 to 16 is equal to 5/4. Okay, so we want to check to see if the other ones are equal to 5/4. So let's do 25 to 20. 25 over 20 is 5/4. And then let's do 30 to 24. It's 5/4. And then finally, 15 to 12 is 5/4, because they're both divisible by 3. All right, so then yes, they would be similar. The scale factor is 5/4. And then the similarity statement would be, can we use what they have here, ZYXW to FGHJ? Yes, that would list the angles in corresponding order. So ZYXW is similar to FGHJ. That's your similarity statement. Okay, if you would say the statement of proportionality, that's where you do the fractions. All right. And then one thing you also want to be careful too is that if you do say that they're similar, all the corresponding angles have to be congruent. Here they clearly are, but sometimes you might need to check. So here, using similar polygons, now we're going to, they're saying that these triangles are similar. So I'm going to go ahead and mark the corresponding side lengths similar. So DE and MN, and then that would be those two and these two. Okay, just in case maybe triangle is flipped or turned around or etc. Now we know the corresponding sides. So then find the value of x. All right, so to find the value of x, let's go ahead and find, first thing that you want to do is find the scale factor. So let's find the scale factor in both directions. So the bigger one to the smaller one would be 16 over 12, or you can use 12 over 9. Maybe I use 12 over 9. It really doesn't matter. 12 over 9 reduces to 4/3. Okay, so then in order to find x, you would have to multiply 20 by the scale factor, but you're not going to want to multiply it by this scale factor because that would make it a bigger number because this is a number greater than 1. So you would want to flip the fraction. So we're going to flip it, so that'd be the smaller one to the bigger one. So then you would multiply, so step 2, multiply 20 times your scale factor of 3/4. So if you reduce this would be 20 over 4 is 5 over 1, and then that would give you 15. So 15 is the length of x. All right, now we're going to take a moment to talk about perimeters of similar polygons. So if two polygons are similar, then the ratios of their perimeters is equal to the ratios of their corresponding side lengths. So basically what you have here is that if you were to find the perimeter of this triangle and the perimeter of that triangle and divide them, then it would be equal to just the ratio of one side length to the other side length. Now, I give you a little hint. It's going to be different with area. Okay, because with area, what you're doing is squaring the side lengths. Or, well, think about like meters squared. It's not that you're squaring the side length. Since you're doing, 1/2 base times height or length times width. So for area, it's the ratio squared. So for example, say your scale factor is 3/5. The scale factor of the area would be 9/25. Okay, you'll see an example like that in your edge elastic. So let's do a little example with that. So actually, I think we'll skip this one because this one is always really too easy. Let's go ahead and look at this one. So find the length of the altitude PS. So here we've got two triangles and they're telling us that they're similar, TPR, TPR. So those are congruent, and then XPZ, so XPZ. So then I'm going to mark the corresponding side lengths or angles congruent. And then in order to find the length of the altitude, we know that this altitude is 20. So we would need to find the scale factor from this triangle to that triangle. So this is just like the other example that we did, except you're finding the altitude. So I'm going to do 12 over 16 reduces to, well, it's divisible by 4, so 3/4. Okay, so then you're going to take 20 and multiply it by 3/4. So this is really the same math even. So then that would be the length of the altitude, PS. All right, and I think that is it for today. So you'll get some more practice in your edge elastic assignment, and I hope you guys have a great day.